In the video ahead, we will be talking about normal distributions, but I'd like to point out before you start watching this video that there were a couple of typos that are made in the video, so you have to change part C 1600 to 1850 calories, and in part D change 1850 to 2000. This does not affect the process of finding probabilities. I just don't want people to get confused as to why I suddenly used 1850 when the problem clearly states 1600 and 2000. So before you watch the video, please make these changes, then proceed to watching the video. Thank you. Okay, normal distributions. So we'd like to do a problem on normal distributions, and here is a good problem which talks about the number of calories consumed or required by an adult male to maintain his current weight, and it is claimed that this particular random variable has a normal distribution with mean 1850 and standard deviation 80 calories. If this statement is true, how can we find the following probabilities A through D? So first we define that X is nothing but the number of calories consumed by a male per day, and next we want to define what X is. Well, X has a distribution that is normal with mean 1850 and standard deviation 80. Now this is a very formal notation, so that means has distribution. That's actually an informal way of mentioning it. It's distributed by, N stands for normal, and that is nothing but the mean, and 80 is the standard deviation. If meant to write SD, not DS. SD stands for standard deviation. Now, we'd like to find these probabilities, and we can do this using the traditional approach, which involves a table, or using a calculator or a computer program such as Excel, or some statistical programming language such as R. But here I'm going to make use of a TI calculator. So let's find the first probability. The first probability states that the probability of X has to be, or X has to be at most 1600 calories, and at most would mean less than or equal to 1600. I'd like to find that probability. Since this is a continuous distribution, whether you write it as less than or equal to or less than, they mean one and the same, because continuous probabilities are nothing but areas under a curve, and for a single point the area is actually 0. So let's make that note here. Probability corresponds to area under the density curve. Now I'm throwing a word here, density curve, and I'll draw the curve now. Anytime we do a normal probability problem, it is advised that you draw a curve like this so that you understand normal distributions in a better way. That's not perfectly normal, but that's the best I could do with this tablet. So that is a normal density curve. It looks like a bar-shaped curve. The mean is 1850, and we write the standard deviation right below. Standard deviation, you can either call it as SD or S, they mean the same thing. Standard deviation is 80, and we'd like to know the probability that the number of calories consumed, which is, by the way, on the x-axis, consumed is less than or equal to 1600. So if 1850 is over here, 1600, this doesn't have to be exact. It has to be an approximate. That is sufficient because we're doing this for our own understanding, that's all. So that is the area I'm looking for, and that area would correspond to the probability p x less than or equal to 1600. Now, how do I find this probability? On a TI calculator, if you look on the left hand side, you could press second, vars, and option number 2 is normal CDF. We can't use a PDF because area is cumulative. If you observe this curve that we just drew, the area is accumulated starting at negative infinity all the way up to 1600. So 1600 is over here, and the line actually goes toward negative infinity. So this probability can be found using the normal CDF function. Do not use PDF. And it has a very standard syntax. You write the starting point, the ending point. When I say start, end, I mean start of the area, end of the area, and you follow it up by the mean and the standard deviation. Now, some books like to call the start and end points as lower and upper endpoints of the area. They actually mean the same. It doesn't matter how you interpret it. So on a calculator, all I have to do is select 2, then press the starting point. If you look at this area, the area started at negative infinity and it goes all the way up to 1600 and it ends at 1600. So in order to represent negative infinity on a calculator, I press negative sign followed by E99. So to get a funky E, you press second comma. That brings up E, and you have negative E99, and that would represent negative infinity. So we started at negative infinity and the area ended at 1600. The next step would be to enter the mean and the standard deviation. The mean is 1850 and the standard deviation is 80. Press enter, and the probability we get is 8.8909 E negative 4, which means 8.89 times 10 raised negative 4. It's a very, very small probability. So what we are trying to say is if the adult male wants to maintain his weight, then he can't be eating a maximum of 1600, because if he only ate 1600 calories, he will probably be losing weight. There is a very high likelihood that he will be losing weight. So can he maintain his weight? What is the probability that he can maintain his weight? It is very, very slim. It's approximately 0. So that's how you find an at most probability using normal CDF. Now, moving on, if we want to find, this is B, if we want to find B, which is the probability that the individual eats at least 2000 calories. Well, at least 2000 calories would mean X is greater than or equal to 2000. So, once again, it's best if we can draw a normal density curve as best as you can. Doesn't have to be perfect. The mean is 1850. The standard deviation is 80, and this variable x is on the x-axis, which is nothing but the number of calories. That doesn't change either. If 1850 is over here, approximately we have something over there as 2000. As I mentioned, we are doing this curve just to help us in understanding what area we are looking at, and this curve need not be accurate. By all means, the curve that I'm sketching is not mathematically accurate, but we're just doing this for the sake of mere understanding. We can be particular about this, but it's not necessary. So the area starts at 2000 and it ends at infinity. So in this particular problem, we will use the same normal CDF, not PDF. We have to use CDF, and we plug in the start point of the area, the end point of the area, the mean, and the standard deviation. In my problem, I have normal CDF. It starts at 2000 and it ends at E99, which is infinity. E99 is just the representation for infinity. We are heading toward the positive side, so we're going toward positive infinity, and we follow it up by the mean. Mean is 1850 and standard deviation is 80. So on a TI calculator, I could press second, thus option number 2, I press 2000 followed by E99. To get E, I press second, comma, 99, comma, the mean 1850, comma, the standard deviation of 80. And that tells me the probability is 0.03039. So there is only about a 3% chance that, given the problem, that this particular individual can maintain his weight without gaining. So you're eating in excess. 2000 calories is in excess, and if you ate at least 2000 calories per day based on the given statement, there is not a very high chance of the individual maintaining his weight. So under what circumstances would an individual be able to maintain weight? Now that particular question can be answered by looking at the answer for question C, or the question in part C, which asks us to find the probability that you eat somewhere between 1850 and 2200. Now let's see what happens in this case. And again, I could draw a sketch, a normal distribution. Doesn't have to be perfect. 1850 is in the middle and standard deviation is 80, and we'd like to find 1850 up to 2200. Something like that would be our area, and that area is nothing but our probability. So 1850 is over here and 2200 is over there. So if I have to plug this in the calculator, I do it as normal CDF 1850, 2200, mean is 1850 and standard deviation is 80. And if I do that using the calculator, why did I do 1850 and 2200 here? Because the starting point of the area is 1850 and the ending point of the area is 2200. Second distribution, number 2, 1850, 2200, 1850, 80. Press enter and the answer turns out to be 0.4999. So this would actually mean it's approximately 50% chance that you will be able to maintain your weight. Well, 50% chance is not a good probability. You can't tell someone, well, there is only a 50% chance that you will be able to maintain your weight if you ate between 1850 and 2200 calories. Now, if we want to give a more confident answer, we could find this probability instead. We could find the probability. I'm just doing this particular part as a continuation for problem C. Instead of finding 1850, let's just change it to 1600 up to 2200. So this is an extra part for problem C. This was not stated in the question. I'm just doing it to demonstrate a point. So if it is 1600 to 2200, then if you sketch a curve, 1850 would be in the middle, standard deviation is AC, 2200 is over there, and 1600 is probably over here, and we want to find the probability between 1600 and 2200. That is our x variable. So if you want to find that area, I could just use normal CDF start, which is 1600, starting point of the area starts at 1600, ending point of the area, which is 2200, followed up by the mean 1850 and the standard deviation 80. And if I put those numbers in, I'll find the probability to be, I press second mouse to get to normal CDF, press 2, and I'll find the probability to be normal CDF 1600, 2200, 1850, 80. Press enter. I get 99.91% or 0.9991 probability. So this would mean 99.91%. So if we want to be very, very sure that an adult male would be able to maintain his weight, then this particular male or any male, based on the statement that was provided to us, should be eating somewhere between 1600 and 2200 calories. Now we are about 99.91% confident that he can maintain his adult weight if he eats between 1600 and 2200 calories. And continuing this thought, if we did problem D asks us to find probability of x equal to 2000 calories, I believe, exactly 2000 calories. Now you might say I could do x is equal to 2000. Well, if it is 2000, the area would start at 2000 and end at 2000 because x is exactly equal to 2000. Let's try to do this using the calculator. Second mass to 2000, you start at 2000 and you end at 2000 because it is exactly at 2000, and you plug in the mean 1850 and the standard deviation is 80. You press enter, you get an answer of 0. So does this make any sense? Well, it should make perfect sense because the data variable that we have is continuous. With a continuous data variable, the exact probability of a continuous data variable is always 0, because with continuous data, probability corresponds to area. So if you recall, probability corresponds to area under the curve, under the distribution or density curve. If that is the case, then probability x equals 2000 is nothing but the area of the point 2000. And we all know a point has no area, so logically this is just a big zero. So normal CDFs are quite easy to find if you have a calculator, especially a TI 8384 calculator. Of course, you could find these probabilities using software, as I mentioned earlier, but for the sake of this class, a calculator is sufficient. So there you go. This is how you'd find probabilities using a normal distribution, and it is important that you understand how to find probabilities using normal distributions, because normal distributions play a significant role in statistics, and you will see this again and again if you take advanced classes in statistics.